We've finished going through all of the basic set operations, so in this video I'm going to do some examples of applying the set operations. The particular examples that I'm going to do in this are from the book Abstract Algebra Theory and Applications by Thomas W. Judson. The first example says let R be the universal set, which is U. And then it defines two sets, A and B. A is the set of all real numbers x such that 0 is strictly less than x, less than or equal to 3. So any real numbers between 0 and 3, not including 0, but including 3. And B is the set of all real numbers between 2 and 4, including 2, but not including 4. We're going to do 5 different examples using these sets. The first one is what is the intersection of A and B? Intersection being everything that A and B have in common. Since A goes up to 3 and B's lowest number is 2, we have that the intersection must be the real numbers between 2 and 3. So this is the set of all x in R such that 2 less than or equal to x less than or equal to 3. And I've done less than or equal in these cases because clearly both sets contain 2 and both sets contain 3. The union is, again, we take everything from both sets. So the union is going to go from 0 to 4, and since we don't include 0 or 4 in the original sets A and B, we're not going to include them here. So 0 is strictly less than x is strictly less than 4. A minus B is where we take A and we remove anything from A that also happens to be in the set B. Therefore, we're going to remove everything from the set A that is bigger than or equal to 2 because B starts at 2. A minus B ends up being the set of all x in R such that A starts at 0, no conflicts there with B, and then it goes up to 2, and we have to do less than 2, not less than or equal, because we don't actually want to include 2, because 2 is in B. We've removed the things from A that are also in B. And then the complement, which I introduced using this notation. This particular book that I'm looking at uses this notation for the complement, so A prime instead of the bar over A. And the complement is going to be everything that is in the universe, but is not in A. Therefore, since our universe is the real numbers, the complement of A will be the set of all x in the real numbers, such that, and then we want x to either be less than or equal to 0, or x is bigger than 3. Since A contains the numbers between 0 and 3, we want to exclude those in the complement. And since A didn't contain 0, we can put that into the complement. And since A did contain 3, we need to remove that from the complement. So we do have to be careful here about using less than or equals or strictly less than. Okay, I am going to stop here.
Say, you ought to buy my electric guitar. You could buy the thing that has made me famous. The guitar.